Hi and welcome to my video. In this video I want to show you an interesting formula that is Euler's formula, and that basically says that how we show the I times theta with cosine and sine and a complex number. We are going to show this by using Taylor series, and let's start with e to the x. In Taylor series we define this a summation that starts with 0 and goes to infinity. And our function here is x to the k over k factorial. I'm sorry, but I'm not going to show that how this is equal to that summation, but in later videos I may show this because I don't want that this video to not that long, and our basic, we want to just prove that the Euler's formula, our focus is that. Okay, let's continue with that. So the first term is k is 0, x to the 0 is 1, and 0 factorial is equal to 1, and that equals to 1 actually, right? So the second term is if k is 1, x to the 1 is equal to x, and 1 factorial is equal to 1. And third term for our k values is 2, right? So k x to the 2 and 2 factorial here. Let's continue and write it a little bit more. X to the 3 and 3 factorial, and for 4 it will be x to the 4 and 4 factorial. I don't have enough room here actually. Let's write it here. X to the 5 over 5 factorial, and I think that's enough. That continues like to the infinity. So that is for x, and let's say that our x is equal to I times theta. So the summation is still same, but we have I times theta for x values. So 1 is 1, but the x will be I times theta over 1 is again this, and I times theta to 2 second power and over 2 factorial, and for this term we have an exponential of 3, and let's write it like that too. And for fourth term, actually fifth term, right, over 4 factorial. And for that term we have I times theta to the power of 5 over 5 factorial, and it continues like that. So let's remember how that I works actually, right? So the first power of I is equal I. It's simple. And the second power of I is equal to -1. So we can write all the remaining terms using these two. I to the 3, for example, it can be written I multiplying I and I to the power of 2. So our I is I, and I to the power of 2 is equal to -1. So that is equal to -I. And let's write I to the power of 4 here, and that is the product of I to the 2 twice times 2, and that was equal to -1, and that's why we can write it like that. Okay, and as I said, it continues like that. For example, I to the 5, I times I to the 4, we can write it like that. I is basically I, and I to the 4 is 1, so that is I. So it's like a circle actually, right? And it goes like that. Although I wrote it so badly here, but you get the idea. It's like a circle. I mean, let's continue with that. I to the 6 will be, if our assumption is right, will be -1, right? Circle assumption. So it is equal to, I hope it's right, I to the 4 and times I to the 2. I to the 4 is equal to 1, and I to the power of 2 is equal -1. So that is -1. So yeah, it's true. And let's continue with we have that I terms, and write this in the summation. So e to the I times theta is equal 1, and they're same. Also I to the theta is same, but we have I to the power of 2, and also for that theta as well. And I'm going to write this fast. I'm just multiply this exponential with these values, because I mean there are 1 here actually, right? I to the power of 1, theta 1, and I multiply with this. It's simple, that's why I'm doing this fast. And let's not forget that 5, yeah, I wrote it so bad. 5 theta 5 over 5 factorial, and it goes on like that. So we have these values, and let's write this again using these values. E to the I times theta is equal 1, and I is still I times theta. And we have I to 2, the second power was equal to -1 here. -1 times theta to the second power over 2 factorial. And the third power, for the third power, we have and minus I. Okay, let's write it like that again, over 2 factorial. And for the fourth power, we have 1, that is equal to 1 here. So we can write it like that. That is a 4 factorial plus, and for 5 we have an I here. Theta to the 5 over 5 factorial, and it goes like that. Okay, now we have this. Let's write it again. And I hope, actually not the last one, that we will have to write it one more time. I hope only one more time. 1 plus I times theta, and okay, not plus sign here, we have a minus here. Minus theta is 2 over 2 factorial, and again a minus here, because plus times minus is equal to minus, and as there is a minus sign here, and theta to the power of 3 over 3 factorial, and they are plus. They're positive terms. 4 over 4 factorial plus I times theta to the 5 over 5 factorial, and it goes like that. I didn't make a... Yeah, I did a mistake here. That should be I here, because the third power of I is equal to minus I, but I wrote only minus 1 here, so that's wrong. I realized here it felt wrong actually, so there is an I here. So we have terms that some of them includes I, but some of them aren't. So let's write this separately. I am going to write the terms that aren't includes I first. We have one first of all, and we have this term over 2 factorial, and that terms includes I. I'm not going to write this, but I'm going to write this plus theta to the 4 over 4 factorial, and it goes like that. And I'm going to write I terms, but I will take a parenthesis of I. So I parenthesis here, and we have theta here, remaining theta, and we have remaining minus sign here, and theta to 3 over 3 factorial, and that term also includes I, and we have a plus sign here, and we take I parentheses, and the remaining term is theta to the power of 5 over 5 factorial, and I'm going to write minus here because it will continue with the minus, I guess like that, and it continues like that. So there is also a Taylor series of 2 Taylor series actually here, right? This one and this one. These are also a summation of some special functions, and for that it is equal to cosine theta, and for that is equal to sine theta. So our e to the I time theta will be equal to cosine theta plus I times sine theta. So that is actually that simple here. So I guess that you probably saw a equation e to the I times pi is equal to minus 1, or it can be also written like if we add 1 to the both sides is equal to 1. So it actually comes from with this equation. Oh my god, what is that? I didn't do this. And for this we have a pi instead of theta. Let's write this pi then. Cosine plus I times sin pi. Okay, we all know that. Okay, let's write the graphs of this. This will be for cosine, and I'm so bad at writing. This will for cosine. Okay, it goes like that. Okay, like that. And this is for sine. So that is 0, and that is 19 pi over 2 actually. And there is the pi, and that is equal to minus 1. Of course, these graphs are between 1 and minus 1. So cosine is equal to minus 1, and sin pi, let's see that it is 0. There is pi over 2 and pi. So that is equal to 1. So if we sum of these two values, not equal sign here, -1 plus 0 is equal to -1. So yeah, that is the as an example. But I want to show you an extra here. If that equation didn't convince you, I'm going to take derivatives of both sides. Okay, let's write this again here. We have this, and I'm going to take derivatives of both sides, and I will check if they are equal or not. So let's write the left part, and I time theta. I'm not going to explain the whole derivative concepts, but it's basically easy. The derivative of e is equal, same here, and it will be multiplied with the derivative of this, and if you take derivative of this, it is equal to I. Okay, and so we said that e to I time theta is equal to this, so it is equal to, like, we have I, and this equal to whole this theta plus I time sine theta, and that will give us I times cos theta plus I squared and sine theta. And we know that I squared was equal to -1, right? So let's write it like that, -1 sine theta, and that is equal to minus sine theta. Okay, we now have this, and let's take the derivative of the right part, cos theta. Okay, don't forget the derivative symbol here, I times sine theta here. So derivative of cosine is equal to sine minus sine, of course, not forget that angle, and sine derivative of sine is equal to positive cosine. There is a plus here, but of course I'm still so bad at writing, and that is also a minus, okay, plus I times cosine theta. So okay, as you all know, I hope you see here, they are equal. Of course, that was a bonus here, an extra part. So that was the whole idea for this video. Then actually I can finish the video here. Thanks for watching the video, and see you on the next video, I hope.